Hey guys, so problem number 1 on the homework, you will notice, is strikingly similar, same wording and everything, to the problem from the textbook here on page 251. So I'm going to work that textbook problem for you. So let's break down for a second what it is exactly that this is asking you. So first of all, x is kind of a given, but this is how we say f of x. And one thing that we mathematicians do that sometimes is very, very frustrating is that we give 8 different names to exactly the same stuff. And while the official definition is a little bit more complicated than what I'm saying, more or less f of x basically is the same thing as saying y. Okay, so you know from your days of graphing and from constructing data displays that on an x and a y axis, on a coordinate plane, the x is the horizontal axis and the y is the vertical axis. So it's basically telling you that y, okay, so if I highlight that, it's telling you that y, not f of x, because again, it really means the same thing. So y is equal to 0.25, and it's telling you that x is, remember, old school, I know it sounds kind of immature and juvenile, but x is greater than 1, or I'm sorry, greater than 0, because the alligator is eating the x. So x is greater than or equal to 0, and less than or equal to 1. So basically x is between 0 and 1. So let's look at, so on a picture, it would look something like this. Y would be 0.25 because it's telling you, so we go up on the axis to 0.25, and the x, because it's between 0 and 1, and I know I'm not drawing this to scale at all. Hopefully you guys know by now my drawings just suck. Sorry about that. So it's basically going to look like a box that is, again, so not drawn to scale now that I'm looking at it, but 0.25 high and 1 wide. So what we're doing, you'll notice that the homework question said, hint, find the area. Well, the area under that function, remember old school, good old base times height. So the base of the rectangle is 1 because it goes between 0 and 1. The height is 0.25. So the area is going to be 0.25 times 1, which means the area of this distribution is 0.25. Now, how do you figure out whether or not that is a PDF? So an essential point for the text is that any continuous PDF must be non-negative, first of all, so it's got to be positive, and the area under the entire PDF must be 1. Well, we just established, right, that the area isn't 1. We found the area of this box, and we found that it was 0.25 times 1, which is 0.25. So therefore, A is not a PDF. And again, because the area underneath the distribution was not 1. So what I think would be helpful is if you guys took a second, pause the video, try to decide whether or not example B, you can tell I'm kind of hiding a little diagram under here. You pause the video, try to figure out yourself. Is this going to be a PDF? Yes or no? And then restart the video when you're ready. Dramatic pause. I'm going to assume that that's what you did. So as you can see here, once again, don't forget that f of x is just another way that we mathematicians like to mess with your head and give stuff different names. It really means y, which is why the vertical axis of my graph goes up to 0.25. Then, and I really shouldn't say we like to mess with your head because there's actually really good reasons that we change the notation. Please don't tell any other teachers I told you that because that's really kind of bad that I just said that. And then because x is between 0 and 4, so in other words, greater than 0 and less than 4, that means the x-axis here is between 0 and 4. So if we multiply our base, which the base is 4, times the height, which is 0.25. Look at that. We get an area of 1. So therefore, that area does represent a PDF. And last but not least, why don't you try to pause the video again for a second. Try to do C. Check this on your own real quick. See what you think. I'm going to assume you've done that, and I'm going to go ahead and scroll up. So again, doesn't quite look the same, does it? Because you notice that's not a rectangle. Instead, this time, it is a triangle. So let's figure out where the heck did that triangle come from. So again, assume that we're changing f of x. Again, there is a good reason that we call it that sometimes. We're going to say y is equal to x. Notice y isn't equal to an actual number this time. Y is equal to x. That means for the entire distribution, the y value and the x value are the same. So how does that translate into a rectangle? Well, if I kind of add a scale here, which I'm just kind of guesstimating, like that's probably 1, and that's probably 1. Okay, so the first coordinate, obviously, if y and x have to be the same, which again, I'm getting that because that right there says that y equals x. That means x and y are the same amount. So if x is 0, then y also has to be 0, so that's why it starts there. If x is 2, y also has to be 2, so that's why we got a little spot there. So it kind of goes like that. So that's where the triangle comes from. So hopefully, if you don't remember, that's okay. I guess that's what I'm here for, right? To remind you, to find the area of a triangle, it's different from finding the area of a rectangle. Because a triangle is really a rectangle that's been chopped in half, right? So the formula for the area of a triangle is 1/2 times the base times the height. So you still do the formula of a rectangle, but then you have to chop it in half. So my base is 2. My height is 2. 2 times 2, of course, is 4. And then half, sorry, my stylus is doing crazy stuff. Half of 4 is equal to 2. So 1/2 times 2 times 2 is actually 2. So once again, area is not 1, so therefore this is not a PDF.